Right, so this is the second of two videos on titrations, and in this one I'm going to focus on the calculations. When I'm doing these questions, I find it really useful to draw out a little table. It just keeps everything really organised, especially in a question like this when they can give you quite a lot of information. So when I'm drawing out my table, I always put the acid and the alkali. So the alkali in this case is the barium hydroxide, and the acid is nitric acid, so I always put the acid and the alkali at the top of the table, and then I fill in volumes, concentration, moles, and ratio. And if we go through the question, and one of the most common mistakes is students just put the numbers in the wrong place. So it's really important that you've identified whether you've been given a concentration or a volume, and for which species they're talking about. So the first one, it says, first bit, it says the student adds 25 centimeters cubed. So 25 centimeters cubed, that's a volume, and they're talking about barium hydroxide. So it's going to go here. When I'm filling the volumes into my table, I always convert them into decimeters cubed by dividing by 1,000. The next line says it titrates the solution by adding something moles per decimeters cubed. So moles per decimeters cubed is going to be concentration, and they're talking about HNO3. I don't need to do any unit conversions with concentration, so I can just plug that number straight in. The equation is shown below, so from the equation I can get the ratio. There's nothing in front of BaOH2, so that's going to be a 1, and in front of nitric acid I've got a 2. And then the last line here, it says the mean titer of the concentration, so they've just given me that same value again. The mean titer is this 26.75, so the titer is just the volume that you added from the burette, and I'm going to fill that in for nitric acid, and again with my volumes I convert to decimeters cubed first. And then to work out the rest of my table, I use the following formula triangle: moles, concentration, and volume. So to work out moles, it's going to be volume times concentration. So I've got 0.02675 times 0.160, and I get an answer of 4.28 by 10 to the minus 3. I then divide that by 2, and I get to 2.14 by 10 to the minus 3, and then I divide that by 0.025, and I get an answer of 0.0856, and that's going to be my concentration. So if you use this table, it just makes it really clear to see what you've done, and it makes it easier for the examiner to mark it and give you potential error carry forward marks even if you make a mistake. There's another question similar down here, which I'm going to get you to have a go at yourself. So it's here, question 9. So what you'll have to do for question 9 initially is you're going to have to work out the mean titer of HCl using these results up here. And once you know the mean titer of HCl, you can also work out the concentration of HCl, which is the question on the next page. So press pause and have a go at working out, first of all, your mean titer using the results in the table, and once you've got the titer, work out the concentration of HCl. So have a go yourself before watching the answer. Okay, so I've started off the question here. I've calculated my titers. You always have to record them to 2 decimal places. And once I have my titers, I look for my concordant results, so the results within 0.1, and I can use that to calculate my mean, which is 24.25. I can then draw my table. So I've got HCl as my acid, and I've got sodium carbonate as my alkali, and again I've got volume, I've got concentration, I've got moles, and I've got ratio. So the mean titer here that I've just calculated, that is the volume of HCl. So it's the mean titer of HCl, so it's the volume of HCl. And again, when I fill in volume, I convert it to decimeters cubed, so I can fill that in there. If I come back up here and look at the rest of the question, the first thing I come to is the equation. I can use that to fill in my ratio. So I've got 1 in front of the sodium carbonate and 2 in front of the HCl. Then I get here and I have a concentration, and it's the concentration of sodium carbonate. So I fill that in for sodium carbonate. And it tells me the size of the flask that I use to make up this solution, but that's not the volume that I actually use in the titration, so I can ignore the 250. I add my hydrochloric acid to a 50 centimeters cubed burette. Again, this is just telling you the size of the burette. That's not the actual volume. The volumes used are these here that you got from the table. And then it says the student pipettes sodium carbonate using a 25. So this is telling you that they have added 25 centimeters cubed from the pipette into the conical flask, and that's going to be your volume of sodium carbonate. And again, with volumes, I transfer it to decimeters cubed. So again, once I've got all of my numbers in the table, I can fill it in. Using my triangle, moles is volume times concentration, so that's going to be 0.0250 times 0.150, and I get 3.75 by 10 to the minus 3. If I times that by 2, according to my ratio, I get 7.5 by 10 to the minus 3, and I'm going to be dividing that by my volume, and I get 0.309, and that's going to be my concentration. The next question we're going to have a look at is similar, but with an added extension. So I'm going to do this one. I'm going to do this one here. Just hold on. Okay, so this next question is a little bit trickier, but it does use the same titration calculation that we've just been working on. So there's quite a lot of information. Again, I think the table really helps you organize the information. It tells you it's about weak acids, and you've got compound A, which is a weak monobasic acid. So that word monobasic there, that means that it has only got one acidic hydrogen. It's got one H plus per molecule. And when you react it with an alkali, NaOH, it's going to react in the ratio 1:1. So for example, HCl is a monobasic acid. There's only one H plus that comes off HCl. So it has a 1:1 ratio with NaOH. H2SO4 is a dibasic acid. There are two H pluses that come off each molecule of H2SO4, and it reacts with NaOH in a 2:1 ratio. So I haven't told you what the acid is, but they are telling you it's going to react in a 1:1 ratio. It tells you that you prepare a solution of this acid in your volumetric flask, and they tell you the mass of the acid that they add. Then you carry out your titration with NaOH. The first thing you're asked to do is calculate the mean titer, which I've just taken from the mark scheme. So you're getting 4 marks for doing that, for just being able to read the initial and the final, working out each of the titers, picking out the concordant, and getting the average. So it's worth quite a lot of marks. And then at the end, they give you the structure of compound A, but you'll see here that they have an R group. And they tell you that that R group is an alkyl group. But that could be any alkyl group, okay? It could just be a CH3, so a methyl group, or it could be a C2H5, an ethyl group, or it could be a C3H7, a propyl group. So you know that the alkyl group just has carbons and hydrogens, but you have no idea how many carbons and how many hydrogens are in that group. So in order to work out what that extra group is going to be, you will have to work out the formula mass of compound A. And when you know the formula mass of compound A, you'll be able to work out what the overall structure is. Again, we've already said that it's monobasic, it's only got one H plus, and if we look at the structure, it has got one carboxylic acid group. Okay, so the carboxylic acid is the only functional group that's going to give up a H plus, even though there's loads of hydrogens in compound A. You're only going to get one H plus. So we're going to have to do out a titration calculation. So I'm going to have compound A on one side, and I'm going to have my sodium hydroxide on the other side. That's what I'm titrating it against. And again, I'm going to do volume, I'm going to do concentration, I'm going to do moles, I'm going to do ratio. Sorry, I don't think I made it very obvious why I'm doing a titration calculation. If I want to work out the formula mass, the only triangle we have with formula mass is G Mr. moles. I've been given G earlier in the question, but I need to find moles. I can use my titration table to find moles, and once I've got G and I've got moles, I can find formula mass. When I know formula mass, I'll be able to work out what this R group is. So if I go back to the top of my question and start looking at the numbers. So this is when they made up the standard solution. I'm not going to be using these numbers in my titration table, but this one here, student titrates 25 centimeters cubed samples of this solution. So they're talking about A, and they're saying the volume is 25 centimeters cubed. So again, I'm going to convert that into decimeters cubed, and I'm going to fill that in. Of this solution with, and then they give me the concentration of NaOH, and it's 0.0840, and that's going to be my concentration of NaOH. Then they carried out the titration, and you worked out that the mean titer of A was 22.5. So I can fill that in. Sorry, mean concentration of, NaOH is in your burette. So this volume here is for NaOH, and it's 22.5. So I can fill in that volume there for NaOH. I already know my ratio is 1:1. I've seen that from the fact that they've told me it's a monobasic acid. So I'm going to work out how many moles of NaOH I have. So 0.02250 times 0.0840. I've got 1.89 by 10 to the minus 3, and here I've got 1.89 by 10 to the minus 3. Now at this part, remember what I'm trying to do here. I'm not asked for the concentration of A, so I could fill in the rest of this table, but it's not going to get me the marks. I'm asked for the formula mass. Well, that's what I need to find out. I've already calculated moles. I don't need to calculate concentration. And earlier on in the question, I've been given grams. So at first glance, I have everything I need to find formula mass. But if you look at the question, you are given grams in 250 centimeters cubed of the solution. So I've got grams, 2.495 grams in 250 centimeters cubed. But I don't know how many moles I've got in 250 centimeters cubed. I know how many moles I have in 25 centimeters cubed, but I don't know how many moles I've got in 250 centimeters cubed. And I need to do that calculation before I can just use G Mr. moles. So I have got 1.89 by 10 to the minus 3 moles in 25 centimeters cubed, okay, because that's the volume of A from my titration. If I convert this from decimeters cubed back to centimeters cubed, that's how many I've got per centimeters cubed. So then I need to scale up. If I've got that many in 25, then how many am I going to have in 250? The difference between 25 and 250, I would need to times by 10. So here as well, I'm going to have to times this by 10. And I'm going to get 1.89 by 10 to the minus 2 moles in 250 centimeters cubed. Now I've got mass and I've got moles, both per 250 centimeters cubed. I can just plug it into my G Mr. moles, and it's going to be 2.495 divided by 1.89 by 10 to the minus 2. So 2.495 divided by 1.89 by 10 to the minus 2. And I get a formula mass of 132. So that tells me that the formula mass of this entire compound is 132. And using that information, I'll then be able to work out the formula of my R group. I'm not going to finish off this question because it talks about chirality and chiral carbons, which we haven't covered at this point. So we can't actually finish the question, but we can use the titration calculation to work out formula mass, which is all you'll be asked in year 12. I found another question similar to this, but probably a little bit easier. Press pause and have a go at this one yourself. Okay, so it's a similar style of question. Again, you're asked to calculate the formula mass. So molar mass is the same as your MR. So you can use the same method that I just did to work out formula mass. Again, the trick here is to note that the mass that they've given you is per 250 centimeters cubed. And when you do your titration table, the moles you get will not be per 250 centimeters cubed. So you'll need to do that before you can plug it into G Mr. moles. So have a go at doing that for yourself. All right, so in this calculation, as I said, I'm going to be using the G Mr. moles in order to find the formula mass. I've already got my grams, I've got my mass there, but I'm going to need to use my titration calculation to work out the moles. I'm titrating A, my unknown, against NaOH, and I need volume, concentration, moles, and ratio. The first line here tells me about making up my standard solution. Neither of these numbers are going to go into my table. There's no room for mass, so that's not going to fit in. And the volume that you've been given there is just the size of the flask that you're using. It's not the volume that you're using in the titration. So it says the solution of A is added to the burette and titration with 25 centimeters cubed volumes of this concentration of NaOH. So that volume there refers to the NaOH, and I need to convert it into decimeters cubed. and the concentration also refers to NaOH. 1 mole of A reacts with 2 moles of NaOH, so there's my ratio. And the student obtains a mean titer. So anytime you're talking about titer, it refers to what's in the burette, and they're telling you that A is in the burette. So that figure there is going to be the volume of A, and again I'm going to put that into decimeters cubed. Once I've got that, I can work out my moles. So by timesing these two numbers, I work out the moles of NaOH, and then, so it's by 10 to the minus 3, and then by using my ratio, I can work out the moles of A, 1.4 by 10 to the minus 3. So I've got my mass of A, I've now worked out moles of A. I'm asked for formula mass. The obvious thing to do then is just do mass divided by moles, but as in the last question, you're given the mass, so 1.513 grams. That's the mass you've got in 250 centimeters cubed. And before you can use your G Mr. Moles, you need to work out how many moles you've got in 250 centimeters cubed. Your titration table works out the number of moles in this volume here. And if I convert this back to centimeters cubed, it's 27.3 centimeters cubed. So I know the number of moles in 27.3 centimeters cubed, but I need to know the number of moles in 250 before I can use my formula triangle. So to do this, I've got 1.4 by 10 to the minus 3 moles in 27.3 centimeters cubed. If I take the number of moles and divide by 27.3, I'll work out how many moles I've got in 1 centimeters cubed. And then if I take that and multiply it by 250, I'll work out how many moles I've got 250 centimeters cubed. So I've got my 1.4 by 10 to the minus 3, I divide it by 27.3 and times it by 250, and I end up with an answer of 0.0128. And that's my moles in 250 centimeters cubed. So now I've got mass and I've got moles, both per 250. I can take my mass, I can divide by my moles, and the answer I get, the answer I get, 118, is my formula mass. And it says to give your answer to the nearest whole number, so that's going to be 118. At the end, it asks you for structure. I mean, this part you could be asked to do because we've covered all of this information. They tell you it's an organic acid. It contains 2 COOH groups. So you know that the whole formula mass is 118. If it has 2 COOH groups, if you work it out, 12 plus 16 plus 16 plus 1, each COOH group has a formula mass of 45, and there are 2 of them. So taken together, those 2 carboxylic acid groups have a formula mass of 90. So my whole molecule has a formula mass of 118. 90 of that is taken up by the carboxylic acids. Then I've got 28 remaining. They tell you that this acid only contains carbon, hydrogen and oxygen. So of the 28 that you've got remaining, you can assume you've just got carbon and hydrogen in there. The mass of a carbon atom is 12. So how many carbons can you fit if you've got 28 left? 2 carbons will give you a formula mass of 24, and that leaves you 4 short, which would suggest you've got 2 carbons and 4 hydrogens, as well as the 2 carboxylic acid groups. So my carboxylic acid groups always have to go at the end of a chain. And what that says to me is that in between the 2 carboxylic acid groups, I have got 2 carbons, and they each have 2 hydrogens. So that will be my structure. And if I double check my answer, I've got an organic acid, it's got 2 carboxylic acid groups as it's supposed to have, and if I work out the formula mass of this particular structure, it should give me an answer of 118. Also, the fact that it's got the 2 carboxylic acid groups matches the fact that I was told that there is a 2:1 ratio. I need 2 moles of NaOH for each acid, which makes sense as it's a dibasic acid. With these titration calculations, you need to practice them. Okay, they all kind of have the same kind of core calculation at heart, but they tend to differ slightly. And the only way to get good at them is to practice and do as many of them as you can. But they are essentially all done in a very similar way. Please just make sure you're showing your workings clearly so that you do get error carry forward marks, even if you make little mistakes.